Welcome to Limits Involving Infinity, a mini lecture for people stranded by the hurricane who have time to study calculus. When we're looking at limits involving infinity on a graph, what we're thinking about is what's happening to the graph as you approach infinity. This is something that this is a common question from pre-calculus. Because what happens to a graph as you approach infinity on the y-axis? Well, that's basically a search for your vertical asymptotes. As you approach infinity on the x-axis, then, is a search for your horizontal asymptotes. And this is all that some limits are. But given an equation, how do we know if there's going to be a vertical asymptote on the graph? Well, that's going to occur every time that you have some non-zero number over 0. Where n is not 0. 0 is divided by 0 usually means there's going to be a hole on the graph. But a non-zero number divided by 0 means there's going to be an asymptote. The nice thing about this is every time you know you're dealing with an asymptote, the graph can only do one of three things. Either both sides of the graph are going up to infinity, both sides of the graph are going down to infinity, negative infinity, or one side will be going up and the other side will be going down. If any of these things are happening, we're going to say that the limit on this graph is infinity, the limit on this graph is negative infinity, and the limit on this graph does not exist because both sides are going in different places. Now, in many calculus books, there appear to be some disagreements on how to define limit. Even the book we use at our school says that a limit has to be a finite number, and everyone knows that infinity is certainly not finite. However, in all these situations, keep in mind that the purpose of limits ultimately is, at first at least, to find slope. And if I were to say draw a slope that is infinite, you'd say, oh, okay, that means we have to go up infinity and over 1. Well, draw a line that has a slope of negative infinity. Well, there we're going to go down infinity and over 1. In the last example, draw a slope that's undefined. For all three of those slopes, you're going to draw the same thing. Ultimately, if any of these things show up as we're finding slope, it means that, at least for a moment, your graph does become vertical. So let's see how some problems here are going to look. First one, we have a limit as x approaches 3 of x over the quantity x minus 3 squared. Well, first step always is plug it in. And when we plug this in, we get 3 over 0 squared, so that's 0. Oh, 3 divided by 0. That must be some sort of vertical asymptote. All we have to do now is figure out from the left and right, are both sides going to positive infinity? Are both sides going to negative infinity? Or does the answer not exist? To find that out, we're going to plug in some numbers really close to 3, and we can do that in our heads pretty efficiently. Let's come from the left first. In the numerator, from the left, so I'm looking at the limit as x approaches 3 from the left. In the numerator, we have a positive 3, right, or 2.9, some positive number. In the denominator, we have 2.9 minus 3, that's going to be negative something, squared. That's going to make it positive. All I care about at this point is whether the numerator and denominator are positive or negative, because I automatically know it's an asymptote. I know it must be going to positive infinity or negative infinity, and the actual values of the numbers don't matter beyond whether they're positive or negative. So from the left, it looks like it's definitely going to positive infinity. Does that mean infinity is your answer? Maybe. We could probably see this already, but as you plug in stuff from the right, we're going to check the limit as x approaches 3 from the right. The numerator is still positive, and the denominator, 3.1 minus 3 is some positive number, and squared is going to make the denominator positive all the time. And yes, this is as easy as looking at the numerator and saying, is that going to be positive or negative? And the denominator, the moment you see it squared, you know it's going to be positive every time. And so from the left, it was positive infinity. From the right, it's positive infinity. So the limit here is positive infinity. Let's move on to another problem. Okay, here we have the limit as x approaches 3 of 2 minus x over the absolute value of x minus 3. We're going to do this the exact same way. We first start always by plugging in x. No matter how good and competent we feel at mathematics, your first step in limit questions is always to plug it in. So when we plug in 3, we get 2 minus x, which is negative 1, 2 minus 3, over the absolute value of 3 minus 3, over 0. We have a number over 0, definitely going to be an asymptote. So is this asymptote going to positive infinity, negative infinity, or is each side going to a different place? Let's start out with the left. The limit as x approaches 3 from the left. So we're plugging in 2.9. When we plug that into the numerator, 2 minus 2.9 is very negative. In the denominator, we plug in 2.9, we get a negative number, but it's the absolute value, and the absolute value there makes it positive. Okay, so from the left, it looks like we're going to negative infinity. We're not confident of the answer unless we check the right also. And this is stuff that most of you could probably pull off in your head pretty easily. From the right, the numerator is negative. The denominator is going to be positive. I'm not even looking at the denominator anymore. The moment I saw absolute value, I knew the denominator is going to be positive no matter what. I'm not even going to consider the expression inside. And a negative divided by a positive is negative infinity. So both sides are going to negative infinity. This asymptote must be going down to negative infinity. All right, one more to check out here. The limit as x approaches 3 of 51 divided by x minus 3. Okay, so first we're going to plug in 3. When we plug in 3, the numerator is 51, and the denominator is 0. 51 over 0, some non-zero number over 0, means that we're going to get an asymptote on the graph, and all we have to do is figure out from the left and right, are we going to the same spot? Let's find out. The limit as x approaches 3, let's go from the left first. All right, the numerator here is 51. That's a positive number. No matter what x is, 51 is positive. Over the denominator is going to be, well, 3 from the left is about 2.9, and 2.9 minus 3 is some negative number. So we're going to negative infinity. Well, before we're confident in the answer, we got to check the limit as x approaches 3 from the right. The numerator is still 51, so it's still positive. And 3 from the right is like 3.1, 3.01. Any number that's to the right of 3, when I plug it into the denominator, that number minus 3 is going to be positive. So here we have a positive divided by a positive. And on the right side of 3 is going to positive infinity, which means this limit does not exist. Graphically, this is the left side. As we get closer and closer to 3, the left side is going to negative infinity, and the right side is going to positive infinity. The limits as x approaches infinity or negative infinity. Either of these are just finding horizontal asymptotes. There were some tricks for finding horizontal asymptotes that you learned in pre-cal, but those tricks don't work for all equations. If trig was involved or if logs were involved, those tricks wouldn't work. And also later on we're going to find other ways to solve these things. However, there are some very simple ones that we need to just be able to look at and understand. And we're going to start these off the same way we always do, and that is we plug in the value. So the limit as x approaches infinity of x over 2 is going to be infinity divided by 2, which is half of infinity. That's infinity still. This next one, the limit as x approaches infinity of 2 over x. Okay, so 2 divided by infinity, what does that mean? This is a weird idea for many students when they first see it, and they think, well, maybe the answer is infinity, and that is exactly wrong. Think about the fraction 2 divided by 2. You'd simplify that and say it's 1. Well, let me increase the denominator. What about 2 divided by 4? Oh, there's 1/2. What about 2 divided by 10? There's 1/5. What about 2 divided by 20? There's 1/100. Every time that we increase the denominator from 2 to 4 to 10 to 20, every time the denominator increased, the value of the fraction got smaller and smaller and smaller. What happens if we increase the denominator all the way up to infinity? That fraction is going to be so small that it may as well be 0. It is an infinitesimal number. It is infinitely close to 0. It's so close to 0 that we can't tell the difference between it and 0. That's all that is. Last problem. I threw this on here just to help people remember the pre-cal rules. If you don't remember the pre-cal rules, I don't care, because they're going to go away very soon. To me, they're more troubling to memorize than it is to just understand what's happening. But the pre-cal rules for these types of polynomial equations, or rational functions rather, sorry, this is not a polynomial. This is a rational equation. It's rational because it's written as a ratio, it's a fraction. But the rule was you compare the exponents, and if the highest exponent is the same as it is here, then all that we can ignore, and your limit is going to be the coefficients of those two highest exponents. So 4/2 or 2. And that's it. Thanks, guys.